In this video, we are going to look at another question of the same chapter. This is a question. 2-point charges Q1 and Q2 are located at points A, 0, 0 and 0, B, 0 respectively. Find the electric field due to both these charges at the point 0, 0, C. So, let's see where these charges Q1 and Q2 are located. So, I will just draw x-axis, y-axis and z-axis. Now, Q1 is located at point A, 0, 0. So, this is the origin. Origin I am going to give a name O and it is located at 0, 0, 0. And Q1, the charge Q1, let me give a name at A at position A, 0, 0. Now, what about the charge Q2? Q2 is located from the coordinate is very much clear, it is on the y-axis. So, I will choose somewhere here that is charge Q2 at B. The coordinates are 0, B, 0. Now, you are asked to find out the electric field due to both these charges at point. I am going to give a name, and where is this point located? The coordinates are 0, 0, C. That means the point is on the Z coordinate. So, I am going to give this point P at coordinate 0, 0, C. Now, how to find the electric field at this point P? You have studied by principle of superposition, electric field at a point due to a system of charges is equal to the vector sum of the electric field at that point due to each of the individual charges. So that means by principle of superposition, electric field at P, I am going to give name E net is equal to, the principle says that it is equal to the vector sum of the electric field due to each of the charges, that is E1 vector plus E2 vector. If there were one more charge, you will just add plus E3 vector. So we have only two charges Q1 and Q2. Now what is this E1 and E2? Now we will take the general formula for electric field at a point due to a point charge. E is equal to 1 by 4 pi epsilon naught Q by R cube into R vector. That is a general expression for finding the electric field at a point due to a point charge. So, let us get an equation for E1. Electric field at P due to this charge Q1, that is E1 vector, is equal to 1 by 4 pi epsilon naught, charge is Q1 divided by. What is the distance from A to P? So, distance from A to P, this position vector, AP cube. I am going to give it name as R1 into AP vector. That is the expression. Now, what is this AP? So, for that, AP vector is equal to OP vector minus OA vector. So, AP vector is equal to OP. What is OP here? It is in Cartesian coordinate, how will you express this OP vector? It is only C k cap minus, what is OA vector? The coordinates of A is A 0 0. The coordinate at O, the origin is 0 0 0. So what is OA vector? It is equal to minus, that is A I cap. Now AP, that distance is equal to R1. R1 vector is equal to, I am just rearranging. No need actually, you can just leave it like that, but I am going to do like this. So R1 vector I got. So I am going to rewrite like this. E1 vector is equal to 1 by 4 pi epsilon naught Q1 by R1 cube into R1 vector. So R1 vector I got. How will I get R1? R1 is the modulus of this R1 vector. That is root of A square plus C square, which is A square plus C square the whole raised to half. So that is E1 vector. Now what is this E2 vector? E2 vector also same way you can write. E2 vector is equal to 1 by 4 pi epsilon naught. It is due to the charge Q2. Electric field at P due to the charge Q2 at B. So, formula. Again refer to the formula. Always keep the general formula by the side. So, Q divided by. What is this R? It is the distance of the charge to the point P. So, what is this distance? Join from B to P. BP. I am going to give it name as R2. So first I will represent the same way like BP cube, that is R cube, into BP vector. So but BP is equal to what? R2. So E2 is equal to E2 vector is equal to 1 by 4 pi epsilon naught Q divided by R2 cube into R2 cap. Okay. Now again, what is this R2? So for that, again we will do the same way. We will follow the same method. Some of you must have already understood that, but still I will do it. What is this BP vector? Equal to, same way. BP vector is equal to OP vector, that is this OP vector, minus OB vector. OP vector minus OB vector. Therefore, BP I named as R2, that distance. R2 vector. What is OP vector? OP vector, that is, already we have written, that is C k cap. Okay. What about OB vector? OB vector is minus, that is BJ cap. So we have to write R2 also. Modulus of R2 vector is equal to root of B square plus C square. I just wrote B first, okay? So you will get B square plus C square the whole raised to half. So that's done. So what is E2 vector? Therefore E2 vector is equal to 1 by 4 pi epsilon naught Q divided by R2 cube, that is B square plus C square the whole raised to half the whole raised to 3. So it becomes 3 by 2. What is this R2 vector? C k cap minus B j cap. Similarly, I will write even vector also. I did not write initially. I will just look here and write 1 by 4 pi epsilon naught, that is Q1. This also, this is Q2, okay, this is Q2, this is also Q2, so Q1 divided by, what is this, R1 cube. R1 cube you can look from here, the modulus, that is A square plus C square, the whole raised to 3 by 2 into minus AI cap plus CK cap. So look at these two equations, E1 vector and E2 vector. So what is the electric field? The net electric field is equal to E1 vector plus E2 vector. Therefore, E net electric field at resultant electric field at P due to these two charges is equal to 1 by 4 pi epsilon naught Q2 Q1 first. Q1 divided by A square plus C square, the whole raised to 3 by 2 into minus AI cap plus CK cap, okay, plus 1 by 4 pi epsilon naught Q2 divided by, what is here, you can substitute B square plus C square, the whole raised to 3 by 2 into CK cap minus BJ cap. That is the expression. You can take the common out 1 by 4 pi epsilon naught, which is not required. This is enough. That's it.